The chi-square test for association gives us one test for which to test for any association between two categorical variables, even if it involves a comparison of more than two proportions. So our hypotheses always follow pretty much the same pattern. Our null hypothesis is that the two variables are not associated, and the alternative hypothesis is that the two variables are associated. So in this case, my explanatory variable is degree held, and my response variable is views about astrology. Note that even though, because these are categorical variables, the test is in some sense comparing proportions, there's not a clean way to write the hypotheses in terms of proportions because it gets rather complicated what comparison we're really making. So we instead make the hypotheses just in terms of our variable names every time. The idea of an expected count is based on the null hypothesis. It says if there really is no association between these two variables, how should the counts be distributed in this table? Our observed counts are these numbers up in the corner. So we saw 44 junior college degree holders who think that astrology is not scientific. If we look down here at scientific, we saw 31 who think that astrology is not or is scientific, but the expected count, 25.2, is how many we would expect to see in this particular cell of the table if, in fact, the degree held tells us nothing about the views about astrology. The way we calculate these is dependent only on the totals. So it's row total times column total over table total. It's taking those totals from the rows and columns and distributing them proportionately among the cells of the table. So to start, we'll recall the table totals that we've already calculated. And let's go ahead and calculate the expected count for junior college not scientific. The row total here is 237. The column total is 75. And the table total is 357. Now we'll put that all into a calculator, for which I get 49.8. Now again, that's the expected count. That's how many junior college degree holders we would expect to see who think that astrology is not scientific, based on the fact that we had 237 people answering that astrology is not scientific, that we had 75 junior college degree holders, and that our table total is 357, assuming that there is no association between these two variables. So go ahead and pause this video right now and calculate the missing expected counts for graduate not scientific and for bachelor scientific, the two empty ones, and then resume the video and see if your answers match mine. I'm getting an expected count of 65.1 for graduate not scientific and an expected count of 61.8 for bachelor scientific. From here, we're going to go on to the chi-square test statistic, which takes into account both the observed count and expected count and calculates a measure of how far apart they are from one another. The formula we use for this is cell by cell we go observed minus expected squared. The squaring makes it positive and also makes it to where if the two numbers are farther apart, then the magnitude is going to be even greater than just the difference of the two numbers. And we always divide by the expected count, not the observed count. So I have these laid out like the top cells of the table, and I'm going to take observed count from junior college not scientific, which is 44, expected count from junior college not scientific, which is 49.8, and the expected count, the one that you enter second, is also the one that goes in the denominator. And putting that into a calculator, I get 0.6755. So let's now do this also for graduate, not scientific. We've got a observed count of 71, an expected count of 65.1, and we would divide by the expected count of 65.1. Go ahead and try that calculation and verify that you get 0.543. Then we can come down to the bottom row and do this last computation for scientific and bachelor degree. I'll go ahead and fill that in just a second. Pause the video, try to fill that calculation in, verify that you get 0.0004. So we would have an observed count of 62 and an expected count of 61.8. Now, as far as your expectations on assignments and tests go, I would say be prepared to calculate any one of these contributions as you're asked to do so. So be prepared to do one of these contribution to chi-square calculations, or two, and be prepared to calculate whatever expected counts are requested of you. I will not ask you to do all of the expected counts and all of the contributions to chi-square by hand in order to get the whole chi-square statistic that we see over here by hand. We will just verify that we can do bits and pieces of it. Anytime that you need a whole chi-square statistic, you can use StatKey, which we'll see how to do very soon. Now, to understand the chi-square statistic, it's helpful to look more closely at some of these calculations. If we look at this middle top calculation here, the 122 and the 122.2 are almost exactly the same, and we can see that we got a very small contribution to the chi-square statistic. Our largest contribution to the chi-square statistic came from this 31 and 25.2, which are a bit further apart. Still not a really big number here at 1.33, but we can see that the farther the expected and observed counts are from each other, in general, the larger the contribution that you will see to the chi-square statistic. This is an important observation for understanding what the chi-square statistic tells us. We can't tell from looking at the number 3.6 whether that's particularly large or small for this question until we go into a distribution, which we're going to do soon. However, we can say that the larger this value is for any given scenario, the stronger the evidence is against the null hypothesis. So this all makes sense because, again, we remember that our null hypothesis is that there is no association between the degree held and the views about astrology. Our expected counts are what we would expect these numbers to be if there is no association, and we see larger contributions to chi-square when the observed and expected counts are farther away from each other or farther apart from each other. Since that's true for each contribution, it holds true for the whole chi-square statistic as well, that the farther apart these are just in general, the larger chi-square test statistic we're going to see.